Welcome back. Today's lesson is lesson 4, sums and products of rational and irrational numbers. So we're going to now take what we know about rational and irrational numbers, and we're going to try to figure out the relationship and what happens when I sum or when I find the product of rational and irrational numbers. So before we start that, please be sure to write today's date in the line above. Keep your notes organized. And we also need to talk about key operation words that you need to know. So you've obviously heard of add, subtract, multiply, and divide, but there are other words, more mathematically correct words that we use for adding, subtracting, multiplying, and dividing. It's really the words that mean the answers to these types of problems. So again, these words mean the answers to these types of problems. So when I'm adding two numbers, I end up finding the sum. So that is a word you're going to need to know. You're going to need to know that sum, if I want to find the sum of two numbers or three numbers, I need to add them. Same thing for subtract. If I'm subtracting two numbers, I am finding the difference. Again, if I'm finding the difference of two numbers, I need to subtract them. For multiply, when I multiply two numbers, that answer is called the product. Again, when I find the product, I'm finding what the answer when I multiply two numbers together. And finally, when I divide, I find the quotient. So when I'm finding the quotient, that means I need to divide those two numbers. And for the purpose of our lesson today, we're going to be focused on sum, which means add, and product, which means difference. So again, these are answers. These are words that we use to describe the answers. Again, make sure you have all that in your notes. These key operation words are words to describe the answers. So sum is the answer when I am adding. Difference is the answer when I subtract. Product is the answer when I multiply. And quotient is the answer when I divide. Pause the video if you need to copy this down. All right, so let's look at these two questions. The first one says the product of the square root of 576 and the square root of 684 is, and then we have four choices. And it looks like two of them are rational and two of them are irrational. So let's start off with this word before we even move on to those answers. We just talked about that word. The word product means the answer when I multiply. So in my calculator, I'm going to need to multiply the square root of 576 and the square root of 684, again, to find the product. And then once I do that, then I'll have a better idea, again, talking about rational and irrational numbers. So let's go to our calculator. Okay, so just a quick reminder where our square root button is. You can actually see it on the left-hand side of my calculator right here above the x squared button, which makes sense because square root and squares are opposites of each other. So if I want to hit the square root button and it's in blue, first thing I have to do is hit second and then that square root button. Now you notice the box is blinking inside. I'm going to stay inside as long as I type unless I arrow out of that box. So I'm going to type in 576. Notice it's telling me to arrow out if I need to get out of it, and I do. So now I'm out of the square root by using the arrow button. And then I'm going to multiply because the question was telling me what is the product. So multiply, and then again I need that square root button, second square root, and I'm going to type 684, arrow out, and I'm going to hit enter. Based on what that answer looks like, because there is no pattern, because the number looks like it continues on and on, that would be considered an irrational number. Now, the choices, if you're looking at them, have that two answers. Irrational because both factors are irrational, or irrational because one factor is irrational. So I need to know what each of these, and when I'm talking about multiplying, each of these numbers are called factors. So I'm going to have to see if each one is irrational or rational. So I'm going to hit enter on just the square root of 576. That answer, because it's a whole number, is rational. Let's see if the square root of 684 is also rational. Ooh, it is not. All right, so let's move back to our worksheet and try to figure out the answer to this question. Okay, so we figured out that the answer to this question is definitely irrational. And that's just by looking at that calculator. I'm going to move my calculator on the other side. Hope that didn't show up, but it might have. Oh well. So right now my answer to this question is 627.68144479, and we're going to assume it keeps going, ... So I'm going to get rid of the two answers that say rational. Again, canceling answers out is a good strategy when we're dealing with multiple choice questions. So now I know that my answer is irrational because it has, again, those two strategies. It continues on forever with no pattern. So, because both factors are talking about the two different numbers. So these two numbers are my factors. Are both factors irrational? Well, actually, the square root of 576 was 24. So that is rational. Let me erase that because that does not look like a 24. Let's try that again. That should be a 4. There we go. But the square root of 684 was irrational. 26.15339,366 ... irrational. So the answer was irrational. Why? Because both of them were irrational? No. Because only one was irrational? Yes. Again, I crossed out choice 1 because it was not both, just one. Now, number 2, we're going to take a little bit more time with, and we're actually going to use the chart on the next page. Which statement is not always true? So there are relationships and there are certain things that we know without a doubt are definitely true all the time when it comes to sums and products of rational and irrational numbers. So I'm going to pause this. We're going to take a pause on this question and we're going to use the chart on the next page and we're going to fill it out with some examples and we'll come back to this question at the very end. So we're going to work through these statements. And again, if you're looking at the bottom of the page, it says, do you have to memorize these? No, but you will have to come up with examples to prove these statements. So again, we're talking about sum means add, and we're talking about product means multiply. So again, you're going to need to know those two words, sum means add, and product means multiply. Erasing points, scribbling these out, sorry guys. All right, so let's come up with some examples. So for the most part, when I'm talking about a rational number, I'm going to use whole numbers because those are always rational numbers. I can always write a whole number as a fraction or a ratio. And when I'm talking about irrational numbers, I'm most likely going to use square roots because most square roots are irrational numbers unless they are perfect squares. So I'm going to give you an example for the first one, the sum of a rational number and an irrational number. So I'm going to add that sum. A rational number, I'm going to give you an example like the number 4. And an irrational number, I'm going to give you an example, again, a square root that I know is not a perfect square, the square root of 2. And when I put that in my calculator, what do I get? And if you have your calculator with you, you should be doing this with me. It's good practice to get you familiar with where those buttons are. And I'm going to assume it keeps going and going. So what do I have here? I have a rational number and an irrational number. And my rule is no matter what, that answer will be irrational. Right, my answer is irrational. Now the sum of two rational numbers. Again, because we're talking about rational numbers, I'm going to use whole numbers as an example. So something like 4 again, and I'm going to add them. So we're talking about sum, and I'm going to just add a whole number. When I put that in my calculator, guess what? I get another whole number. And even if I wanted to go crazy and add another type of rational number, like, I don't know, a fraction, or like an integer, a negative number, I'm still going to get, right, a number that is rational. So no matter what, when I add two rational numbers, I will get a rational answer. Now, the sum of two irrational numbers. So again, I'm going to use square roots as my irrational numbers. So like, let's say the square root of 2, and let's just pick a different square root just for the sake of adding a different number. Square root of 3. I know both of those are irrational numbers. They go on forever with no pattern. And when I add those together, guess what? I'm going to get another number that has no pattern and goes on forever. Sorry, this should be closer together. Dot, dot, dot. So that's an irrational number. However, sometimes it is irrational. There's one little like, oh man, there's like a little tricky like but. That's a little star right there. Sorry, my stars are not so great. Here we go, let's try it again. If I add the square root of 2 and I add the negative square root of 2, I'm going to end up with 0. And actually, 0 is rational. So that's kind of like a trick. Like there is technically one type of answer, one type of situation. If I add, I will get a rational answer. So I'm going to write is sometimes irrational. And again, I would say most of the time, when you add two irrational numbers, you will get an irrational answer. Moving on to products. So products, again, when I'm multiplying, and this time I'm multiplying a rational number and an irrational number. So I'm going to use the same kind of 2 that I used up at the top. I'm going to use my whole number 4, and I'm going to multiply that by the square root of 2, my irrational number. And guess what I'm going to get? A big irrational number. 6, 5, 6, 8, 5, 4, 2, 4, 9, dot, dot, dot. So that is always going to be irrational. Product of two rational numbers. Again, I'm going to use my whole numbers like I used up here, like 4 times 6. I'm going to get a nice rational number, 24. Even if I use two different types of rational numbers, like a fraction and an integer, like a negative number, I'm still going to get a rational number. So no matter what, my answers are going to be rational. Now, two irrational numbers. I'm going to use the 2 I used up here. The square root of 2 times the square root of 3. And when I multiply those, I'm going to get a big irrational number. I call them big numbers, even though they're not really large in size. I call them big, and I use that describing word because they're long. They kind of go on forever. So it's a long number. It goes on forever, no pattern. That makes it irrational. However, there is a trick as well. If I take a square root, like 3, and I multiply it by itself, watch what happens. It's actually the square root of 9, which in your calculator, if you multiply the square root of 3 times the square root of 3, you're actually just going to get 3. So again, product of two irrational numbers is sometimes irrational. Again, there are some situations that I can make it rational, but it does not happen very often. So make sure you have these notes copied, pause the video if you need to, and we're going to go back to that second question on the front page. So back to this type of question. If this question came on my Regents exam, and obviously I hadn't had that lesson that we just had, the first thing I would be doing is remembering sum and product, and I'd also have to remember some kind of rational and some kind of irrational number. So, first question 2. Which statement is not always true? The sum of two rational numbers is rational. So again, if I'm thinking of two numbers, right, our whole numbers, 4 and 6, I'm adding them together because we're talking about sum. No matter which two numbers I pick, I will always get an irrational number. That is always true. We want to know which one's not always true. The second one, the product of two irrational numbers is rational. Again, if I think of an irrational number, like, I don't know, the square root of something. Thing got all crazy. Think of an irrational number like the square root of 3, and this time I'm talking about product, and I multiply it by the square root of 2. Is it going to be rational? No, it's not. It's going to be irrational. So I'm going to wait on that one. How about the next one? The sum of a rational number and an irrational number is irrational. Is that always true? If I take a rational number and I add it to an irrational number, is that always going to be irrational? Yes. The product of a non-zero rational number. So the only reason they're specifying non-zero is because 0 is technically a rational number. So product of a non-zero rational number, okay, and an irrational number, will that always be irrational? And it will. So the only one that is not always true is technically number 2, because right here I proved it. If I have two irrational numbers, is it always rational? No. Sometimes, and I just proved it, it's irrational. So the correct answer is choice 2. Hope you have all these notes copied. Can't wait to see you guys in class.